Welcome back to Upgrade to General, a series to help you upgrade your amateur radio license to general class. This episode is sub-element G4, question group C, and I'm your host, Ron Call. This question set is about interference to consumer electronics, grounding, and bonding. So let's jump in and get started. Question 1. Which of the following might be useful in reducing RF interference to audio frequency circuits? So again, RF is radio frequency. So very high frequency, that's what we're going to transmit from a transmitter. And sometimes that radio frequency can be picked up by any metal. Any metal would act like an antenna. Sometimes audio frequency circuits like speakers, even a computer monitor, stereos, they'll pick up some of this radio frequency interference as if they're an antenna. And you can hear that in the speakers. You might see it cause flickering on your computer monitor. You can hear it on a stereo. So that's a problem we don't want to have. So one thing that can help reduce that in an audio frequency circuit is a bypass capacitor. Capacitors are used in filter circuits. The value of the capacitance determines what frequencies are passed through and which ones are blocked. So if you select the correct capacitor, you can block the RF frequencies but allow audio frequencies through. So essentially a bypass capacitor decouples RF from the audio circuits. Sometimes they're also called decoupling capacitors. The answer here is bypass capacitor. Next question. Which of the following could be a cause of interference covering a wide range of frequencies? Now, when you have a lightning strike, it generates radio frequencies at a variety of frequencies. So any sparking, arcing. So the answer to this question is arcing at a poor electrical connection. If you have current traveling through and it has to spark or arc from one place to the next, you're going to get essentially just like lightning strikes, a whole bunch of radio frequencies produced. Next question. What sound is heard from an audio device experiencing RF interference from a single sideband phone transmitter? That's a voice transmission, so you're going to hear people's speech, but it's going to sound distorted. So the answer, distorted speech. Next question. What sound is heard from an audio device experiencing RF interference from a CW transmitter? Now CW, that's Morse code. Essentially it's going to sound like distorted Morse code. You're going to hear on and off clicking or on and off humming. So that's the answer, on-off humming or clicking. Next question. What is a possible cause of high voltages that produce RF burns? Radio frequency burns are horrible. It's like getting microwaved. It burns from the inside. The idea with your equipment is you're going to transmit and you want the power to flow from your transmitter through the transmission line out to the antenna and then be radiated away as an electromagnetic field. But if the impedance of your feed line or the antenna or the ground wire is so high, it's not going to allow that current to flow through. And instead, that current might find an easier path out through, say, the equipment enclosure or chassis, say even to your hand if you're touching it, and to ground. So one possible cause of high voltages that produce RF burns is that the ground wire has high impedance on that particular frequency. So whatever you're trying to transmit on, if the ground wire has a high impedance there, then the current could find an easier path, say, through you and cause an RF burn. So it's important to check your ground wires, make sure that the ground wire is actually grounded well. Next question. What is a possible effect of a resonant ground connection? This is similar to the last question. Again, you're going to have high RF voltages on the enclosures of the station equipment, on the outside enclosures or the chassis. Again, check your ground connection, make sure that the equipment is grounded well. Next question. Why should soldered joints not be used in lightning protection for ground connections? A soldered joint will likely be destroyed by the heat of a lightning strike. It gets so hot that solder will melt, and that's going to cause a problem later on. So use a mechanical connection, not soldered connections. Next question. Which of the following would reduce RF interference caused by common mode current on an audio cable? I'm not going to go into all what is common mode current, but the thing you often see are ferrite chokes on the cable. A ferrite is a sort of a compressed powdered metal, and if you run the cable through that choke, then the magnetic field from the choke interferes with the magnetic field generated by current moving on the cable, and so that's going to reduce the common mode current. Now, the more times you wrap that cable through the choke, the greater the magnetic field is going to work to impede that common mode current. Next question, how can the effects of ground loops be minimized? Well, a ground loop is if you have different ground levels, different voltage levels, depending on what it's grounded to. So you want everything in your station to be at the same voltage level when connected to ground. So the answer is bond all your equipment enclosures together. Use metal straps or metal cable of some kind. Braided wire or metal strap is some of the best, and just connect all the enclosures together. Next question, what could be a symptom caused by a ground loop in your station's audio connections? A ground loop is current's going to be moving because there's different voltage levels between portions of your station. So you could receive a report of hum on your station's transmitted signal. That's the symptom of a ground loop. If someone tells you, hey, it sounds like you've got a hum on your signal, that indicates possibly a ground loop. So check to make sure all your equipment's bonded together. Next question, what technique helps to minimize RF hotspots in an amateur station? Well, an RF hotspot is an area where radio frequencies are in existence. So you don't want that. You want the RF to be channeled out through the transmission line to the antenna. If you have all the equipment enclosures bonded together, that's going to minimize RF hotspots. Again, answer, bonding all the equipment enclosures together. Next question, why must all metal enclosures of station equipment be grounded? Because RF can radiate and be picked up by the metal enclosures, which act as an antenna, and that's going to have voltages, possibly allow currents to flow along the metal enclosures onto the chassis. So what metal enclosures do when you connect them to ground is it allows a place for that current to flow to ground. The answer is that it ensures that hazardous voltages cannot appear on the chassis. That's it for this question set. Hope you learned something. Look forward to seeing you at the next episode. Thanks again. This is KE7CR 73.